Welcome to Fox Weather Philly on this chilly Wednesday. I'm meteorologist Kathy Orr.
So good to be with you. I'm meteorologist Drew Anderson, and we got my buddy from West Coast University.
Yes.
I've had the pleasure of working with Marc for so many years. You literally wrote a textbook for your Galaxy and Cosmos class, which I think is so cool. To say you wrote a textbook.
Which is awesome. And Professor Gagné, you were with us for that great celestial event when we were previewing the eclipse. It's been a while. How you doing?
I'm doing well. How are you?
We're good. There's been so many interesting, exciting things going on in the cosmos that we wanted to get your take on everything going on. So, of course, the aurora last week and now the comet. Do you know how to say the name? I tried. I think it's like Tsuchinshan or Shane.
Yeah, Tsuchinshan-ATLAS.
Yes.
I'm much more comfortable with numbers, so I just call it Comet A3.
A3. That's what I've been doing.
A3 is good.
I like
A3.
A3. So tell us a little bit about the comet. We have some pictures that folks have taken from across the Delaware Valley, and it's very interesting because last night this young woman, Catherine in Cherry Hill, sent us a picture, and then we've seen other ones with spotlights, the spotlight effect, which is really neat. And looking in the sky tonight, it looks like it's going to be north of Venus in the sky. And as far as viewing, when is the best time to get out there?
So it's actually going to get progressively better over the next few days.
Okay.
Interestingly, the comet is actually getting further and further from the sun right now. So in principle, it's actually dimmer. But as you saw from your graphic, it's getting higher and higher above the horizon as it moves away from the Earth. So it is brightest not only when it's close to the sun, but also when it's close to the Earth, obviously. So right now it is moving away from the sun and away from the Earth slightly. But because it is rising in our skies, it'll be visible later in the evening when it's a little bit darker. And it'll also be visible higher in the sky where there's less sky glow from light pollution. The other thing to keep in mind is that right now, tonight and tomorrow is full moon. So the moonlight actually makes it harder to see the comet. So if you wait a couple of days as we go from full moon to third quarter, that third quarter moon is going to be getting up later in the evening. So in a few days, if the skies are clear, are going to be ideal for viewing the comet. And as you say, basically look southwest, close to Venus, and look up. Currently, it's kind of near a constellation called Ophiuchus, which is next to Scorpio. But basically, it is going to be moving up towards a very bright star called Arcturus, which is easily found. In fact, if you follow the handle of the Big Dipper, you arc to Arcturus, and it'll be basically just below Arcturus in the sky in the next few days.
So you look by the Big Dipper, and then Marc, you recommend what? Going out after sunset? Sunset's what, 6:30, so maybe 7:45, particularly later this week?
Exactly. So if you go this week, you'll have to go fairly soon after sunset because it is close to that southern horizon, that western horizon. But if you wait a few days, it'll be higher up, and so you can go a little later when it's darker. The other thing I recommend is that if you can find a good pair of binoculars, even not necessarily astronomy binoculars, but binoculars that you might use for bird watching. Typically, they're called 10 by 50 binoculars, fairly standard binoculars. That'll really help with the light collection, and it'll also give you that 5 times magnification, and you'll be able to see it. But as you just showed, Kathy, some of your viewers were able to get outstanding pictures just with their iPhones. So
absolutely, which is amazing. So in order to view the comet this week, we mentioned a few of these things. Look in the western sky, visible to the naked eye, but better with binoculars. And at least for tonight, tomorrow night, best viewing 1 or 2 hours after sunset in that 7:30 to 8:30. But as you mentioned, Professor, we have to consider the moonlight the next couple of days as well, and then it will be higher in the sky so we can go out later over the course of the weekend. And you know what? It will be a little warmer in those evenings as well when we're trying to get out there. So it will be a plus. How much of an impact do you think the moon will have on this since it's so bright?
Not so much, because this is a fairly bright comet, so it shouldn't be so bad. As you saw, you showed some photos, the moon was probably up when those photos were taken, and yet your viewer was able to get a good photo.
Yeah,
The
in
other
fact,
thing I
last
wanna-
night, Mark, I'll just jump in on that. What was really cool was we got some great pictures last night, and the moon was, pretty big and pretty bright. And
Yeah.
what you clued me into is if we wait those couple days, the moon's not coming up right at sunset. And as you know, only the full moon's up all night, so that's great to have a darker sky. It might make it
Absolutely.
even easier to see
Maybe
it.
easier. Let me show you this picture because I had part of it covered earlier. So this was from Catherine in Cherry Hill, and I circled the comet because it was right over the house. I don't know if you can see that, Professor, but
Yep.
you can see that spotlight effect, which is so cool because you're looking at the other stars in the upper left, and they're so bright. And this, you can see, it has a little bit of that spotlight effect, which you can see
Right.
a lot better
You see the
in
tail.
this next photo.
And the other thing that's interesting about this particular comet is that it's an Oort cloud comet. What that means is that it lived for 4.5 billion years in a very, very distant part of the solar system. In fact, it is about a third of the way to the next star. It is the outer edges of the cloud from which the sun and the planets and the solar system formed. Those rocks, those comets, basically dirty snowballs, have been sitting there for 4.6 billion years doing nothing. And then occasionally something will perturb it, either a close encounter with another object, a passing star, something perturbs its orbit and it begins to fall into the sun. And it is on basically a parabolic trajectory, which means that it is headed straight into the inner solar system. It actually grazes the orbit of Mercury and then heads back out of the solar system, and it will never return.
Wow. So is that why we're seeing it now? Because this was discovered in 2023, and
As it was incoming into the solar system. So the Chinese were the first at Purple Mountain Observatory, were the first ones to discover the comet, and then it was actually found in other telescope data. And they've been able to track the orbit very, very carefully. They've measured the eccentricity of the orbit, and it is basically a perfect parabolic orbit.
Mark, do you know, by the way, how they discovered it? Was it with a telescope you just would see with your eyes, or was it a radio telescope where they're just listening?
No,
for
it was a
kind of energy?
regular optical telescope.
Wow.
And basically what you do, and it's interesting because in the early 1700s, this is, 300 years ago, comet hunting was probably the number one activity that astronomers did. And so basically, today, obviously, they use electronic, digital photographs, but basically they look for any object which is moving with respect to those background stars behind. And that's how all of these objects, asteroids, comets, dwarf planets in the solar system beyond the orbit of Neptune. That's how all of these objects are discovered by their motion with respect to the background stars. And there are computer algorithms that literally subtract those images to find the moving object.
Wow, this is fascinating. One quick question before the break, though, Professor. Is this unusual to see a comet kind of come out of nowhere for us lay people
It is not.
so recently?
It is not. It happens every few years. Once in a while, we have some spectacular examples where it'll come into the inner solar system and then happen to cross the orbit of one of the planets. And so years ago, comet Shoemaker-Levy actually impacted Jupiter that way, eventually being attracted by the gravity of that giant planet and actually impacting the surface of the planet. This isn't rare because there are probably, I don't know what the number is, but there are millions upon millions of these big, dirty snowballs floating around the outer edges, the very outer edges. I can't tell you how far it is. We're talking about 100,000 times farther than the sun. They are literally sitting there in a kind of a hovering orbit around the sun. And then because there are so many of them over the course of billions of years, in fact, there must be billions of them out there because every few years we see one.
Wow,
And this has been happening for 4.5 billion years.
Yeah, and now we have to pay more attention, right?
Yes, and so one of the concerns, of course, is that someday, and I don't know when that is, in 10 million years or 5 million years or 20 million years, one of these large objects is actually going to impact the Earth. This has happened in the past, and it will happen in the future. We just don't know when.
Yeah. Well, we don't want to talk too much about that.
Well, that's actually why NASA has the NEAR program, the Near Earth
exactly.
Asteroid program, to spot these things. And we could do an entire segment on the DART mission from last year that actually impacted one of these asteroids.
Huh, we
To
actually
see if
should.
we could divert its
Right.
orbit.
Redirect it.
Actually, yes, to redirect it. Yeah, for sure. The
Absolutely.
science that's protecting us from the cosmos.
Exactly.
Definitely. We'll definitely follow up with that, Professor. But in the meantime, if you'll stay with us through the break, we have to talk about the Aurora Borealis, because last
Absolutely.
week, Drew and I saw it for the first time in the city of Philadelphia,
Yeah.
with many people across the Delaware Valley. So we're going to take a short break. We'll be back in 2 minutes with Professor Gagné from Westchester University. Welcome back to Fox Weather Philly. I'm meteorologist Kathy Orr with my colleague here, Drew Anderson, and we are having a fascinating conversation about the cosmos. Of course, the comet that will be able to be seen through the rest of the week and into the weekend, and also the aurora, which is very exciting as well.
One of the things that I think is so cool, Mark, that you do is you work with so many students across Westchester University doing research. We were talking just a moment ago, what's some of the research you do with modeling in space? That fascinated me with some of the computer science majors that's similar to our weather future radars and weather models.
So basically, we model the atmosphere of a star.
Wow.
In our computer simulations. And these are massive stars. The stars I work on are stars that are 30, 40 solar masses. So 30 or 40 times the mass of the sun, about 10 to 100 times the size of the sun. And these stars are so luminous that some of them are 500,000 times the luminosity of the sun. That luminosity literally drives mass off the surface of the sun. So, for example, the solar wind is what causes aurorae. Okay, so we're going to talk about that in a minute. But the mass loss on these other stars is millions of times larger than the mass loss that we see from the sun. And as a result, if that star has a magnetic field, and by the way, the magnetic activity on the sun is what causes the solar wind and the aurorae and the coronal mass ejections that lead to these solar storms that we observe on Earth. When a star with a very large mass loss rate also has a magnetic field, that leads to all kinds of shock physics in that magnetosphere of the star. So just like the Earth has a magnetosphere, just like the sun has a magnetosphere, some stars have magnetospheres, but are much more powerful. And in fact, the largest magnetosphere in the solar system is on Jupiter. And so this whole study of magnetospheric physics and atmospheric modeling is something that astronomers, planetary scientists, and meteorologists do. And obviously climate scientists do it over very long periods of time.
Wow, that's fascinating. As far
And
as
we use the same supercomputers that the meteorologists use.
wow, just for different purposes.
Right.
So all in the name of great science, that's for sure. Well, Professor, let's talk a little bit about those solar storms on the sun, the solar flares. So there's a solar storm, it hurls energy into Earth's magnetic field, and then sometimes we get disruptions of satellites, our cell phones, the power grid in extreme cases, but the byproduct is this beautiful color that we see.
Absolutely. And so really what you're seeing is the fact that the solar wind is made of charged particles, electrons, protons, helium nuclei. And it's ionized really by the high energy, by the corona of the sun. And then it moves out at hundreds of kilometers per second through interplanetary space. And when one of those large solar storms leads to what we call a coronal mass ejection, a blob of plasma will move at hundreds of miles per second towards the Earth. And if the Earth happens to be in its orbit to catch that blob, then that blob interacts with the magnetic field of the Earth and will cause the magnetosphere and the magnetotail of the Earth's magnetic field to buckle. And the reason we have a magnetotail is precisely because that wind is blowing past this magnetic field and pulling on the magnetic field. And so there's a sort of steady shape to the Earth's magnetosphere in that magnetotail, which is facing away from the sun. And then when the coronal mass ejection comes, it completely buckles that. There's magnetic reconnection, which happens in the upper atmosphere of the Earth. It leads to particles, energetic particles falling into the Earth. And then as those atoms that are excited, they emit light. That's what light is. That's what matter does. And so we see this light. And you had a little figure up a moment ago that showed the area around the North Magnetic Pole where we tend to see aurorae. And what happens during a solar storm is that at night, realize that we're facing away from the sun. So what we are seeing is the result of the reshaping of the magnetotail.
Wow.
That's neat.
And so as we are facing away from the sun now, we see the effects of the aurorae. And what's interesting is that in North America, we're going to be able to see aurorae to much lower latitudes than we would if we were living in Europe or Asia or some other place. And so it is just happens to be advantageous that the shape of the magnetic field over North America allows us to see these aurorae at fairly southern latitudes.
Well, it
Now,
it is interesting just because last week when we saw it here in the Delaware Valley, I had a friend that was in North Carolina and they rolled on a camera. He's a meteorologist down there, just on like a city cam, and they could see it on their city cam. I mean, that's really something in North Carolina. So I know that we're in this 11-year cycle of peak activity. So how many more opportunities do you think we're going to have to see something like we saw last week?
So what the NOAA, and you guys know, of course, what NOAA is, they are not only sort of telling us about the weather, they're also telling us about space weather. And they have an index called the KP index, which indicates the severity of the solar weather and the extent to which the magnetosphere is going to be sort of distorted by that activity. And so if you go to the NOAA website, they will tell you that on a particular day at a particular time in a particular region, you can expect a KP value of something. In order to see stuff all the way down to Pennsylvania, North Carolina, Virginia, you really are going to need a KP value of 8 or 9. And so it is very difficult to assess how often this could occur. We are entering solar maximum now. We can actually expect solar maximum to last through the majority of 2025. So if we have solar storms, that's what I was talking about.
Yeah. Now that was last week's, just to make a note, that's as likely visible again tonight. That was from last week, but just to give you an idea of what it looks like.
Yeah, what areas could see those northern lights. And that's great to hear that we're kind of in this period of the sun sending out those bigger blasts that you mentioned that reshape some of our magnetic field to give us the opportunities for those northern lights to come a little farther south than usual. So there's hope as we head into 2025.
Yes. And we'll be checking the NOAA website and, of course, the forecast, because this comes out every night.
And one of the things that you can do, of course, is warn your viewers, look, we
want to excite our viewers.
Look up. NOAA is predicting that, in a day and a half from now, that belt, that red and green belt, will be extending down to this region, and then people can go out. I think a lot of people were surprised, as I was, actually, if I'm being completely honest, by the aurorae that we saw the other night. But it's a beautiful thing. And I know that this is the third time I've experienced this in the last 25-ish years.
Here?
That I've been here, yes.
Yeah. Wow.
So this is the third time. So, and basically that's once per solar maximum. And so this may not happen again, but it might.
Okay, we're going to keep our fingers crossed, Professor. Well, Professor Marc Gagné from Westchester University, it has been a pleasure. We'd love to have you back soon to talk more about the cosmos, the asteroids, the comets, everything that's being done to protect us here, and anything else interesting that's going on in space.
Yeah. So by the way, NASA just launched a huge mission to the Europa moon of Jupiter just 2 days ago. But it'll take 5.5 years for it to travel there, so we won't be getting any pictures anytime soon.
Well, we'll save that for 5 years from
Exactly.
now. We have a lot to talk about.
It's in the calendar. I'm going to write it down.
Thanks again, Professor. We're going to take a short break. We'll be back with more of Fox Weather Philly after this.